with that, we see the fires lit, the engines start to roar, and lift off. Scott Tingle, Anton Shkaplerov, and Norishi Kanai on their way to the station.
7, 6, 5.
You're becoming a bit of a regular, aren't you, over there in Plesetsk?
Yes, we've been in Plesetsk a few times. Last October we launched Sentinel-3B. 2 years ago we launched Sentinel-3A, the sister satellite that the Sentinel-3B will soon join in space.
Guido Lovrini, thank you very much indeed. Best wishes to the teams there as we get closer now to the launch. We are 5 minutes and 31 seconds. We are looking at the pad here over there in Plesetsk, about 1,000, just under, I believe, kilometers north of Moscow. And we are getting closer now to launch, but earlier, well, actually several days ago, the satellite went through its integration phase. The satellite arrived in Plesetsk in mid-March, and since then it's been prepared for launch. Nick, do you want to tell us what's going on here?
So during this phase, the spacecraft was placed onto the mating adapter, which holds the spacecraft in place between the launcher and the rest of the satellite. The whole thing was then bolted on top of the Breeze upper stage. Now this is a very delicate operation since both the Breeze KM and Sentinel-3 were fueled at the time. Then after that, there was the encapsulation inside the fairing. The fairing is this honeycomb structure that protects the satellite from the initial during the initial phases of the launch, to protect it from the heat in the atmosphere.
And here we can see
the final mating of the two sides of the fairing, so along the long edge where they bolt together, and this part has to come away flawlessly when we reach the right moment. Then we put on the stickers, and the team sign it and wish the spacecraft goodbye and wish it well on its flight. And here that you see that it's already been wrapped in its thermal blankets, so this protects it from the temperatures and keeps everything in a stable thermal environment during the part of the ascent.
Philippe, the next phase then is to roll it out to the pad.
Yes, indeed, and this is what we see here. Those are pictures that were taken 6 days ago, and the overall, what we call the composite, that is a Breeze upper stage with a satellite under its fairing.
Yes. Now I have audio. Yes. Okay, so
to the tower.
I was
mated, and this is what
telling you this all the time. It's going so rokot, 2-stage vehicle with a Breeze KM upper stage, which is basically the same upper stage they use on a Proton rocket without the extra tank. They will launch it in a sun-synchronous orbit, so every time you will you will come over Paris for let's say Paris. It's 12 o'clock every time you come right over Paris. and the orbit is about 500 kilometers. So yeah, it will. The ascent phase will last about 80 minutes. So the first, they will fire the first stage, separate it, fire the second stage, separate it, fire the upper stage, and then they will have a coast phase, and then they will circularize the orbit, and then they will separate the satellite. And I believe this orbit is, or actually, the orbit, its twin, it's being launched. Right at the moment, its twin is about a 180 degrees. So when it's opposite, on the opposite side of the Earth. So these two satellites will be orbiting 180 degrees from each other. So they will both map the Earth, but they will they can cover the Earth faster than with only one satellite. That's why the whole Sentinel family has an A and a B.
For the launch of the Sentinel-3B satellite.
And I believe this is the last of the family to launch, because the 4 will be launching in 2020, so we won't have Sentinel launches for a long time. But after they finish the launch, I will check on it, and so you'll hear from me. So yeah, let's launch this. So what you will see is a really fast flash of light, and that's because they use a certain type of rocket, and we'll explain it when it is launched. We have no fire yet. Yeah, there we go. Wow, that leaps off quickly. There it goes, you see it rolling. Will we be able to see you? I will, after it finishes launching and it is in its coast phase, I will see if I can get it working. But I had some internet problems. That's why. So there you can see the rokot. You can see all the data, all the acceleration. This is live telemetry. So actually, rokot, where the lettering is, that's the first stage. Then you will see a smaller band, actually, that's a part of the interstage. And then the other white stuff under the black ring actually is the second stage. And then no, that's not in the inside of the black thing, that's the interstage of the Breeze KM upper stage.
Similar to launching a ship at sea, you know.
So
worked for it, you've waited for this moment, and here
there you can see the
beautiful pictures that we've been able to witness, I have to say, with a clear sky.
Oh yeah, another part of this launch, we don't know if it has inserted successfully until we get contact of the satellite. This is because it's a polar orbit, and
in a very smooth environment.
I believe it loses contact just before it goes over the North Pole. There can you see the verniers firing of the second stage. So there is the staging. And next up will be the fairing separation, which will reveal the satellite.
Right now we have separation of
so I
stage.
think during this burn or during the just after separation and ignition of the first or of the upper stage, you will see oh, there it is. You see leaving visibility zone. That's the last time they get telemetry from this rocket, and we don't know if it has successfully launched until we see the contact of the satellite, which will be over Germany. They will get it at Darmstadt, I believe, directly. And then we will know if it has launched successfully or not. So after they lose contact, it's about 80 minutes until we know if it has launched successfully.
Up there and in the forefront as a spearhead of the breeze.
Don't know if you're
So we've
commentating. I am
what's often
commentating.
known as the Kármán line, which is
Can't you hear
effectively
me?
the border with space. It's
It says you
100 kilometers
can,
above
but
sea level,
I don't know.
62 miles. What does that actually mean, Nick?
So at this point, the air is so thin that the force required to
am I too soft? Am I fit?
Is more than actually a rocket needs to fly in an astronautics domain. So this is really the rocket science that needs to keep us there, and it's the boundary between aeronautic ending and astronautic beginning.
And it was identified by a Hungarian-American aerospace engineer called Theodor von Kármán, and he was born in 1881. So we're burning the second stage, getting closer now to the next phase, which will be the second stage shutdown. These images that we're looking at, these are computer-generated images, which are a simulation of what's been planned for the flight. The experts put a lot of information into the computer to generate them. And the second stage shutdown is coming up.
Hmm.
And this is the scheduled moment now for the upper stage to switch off and switch on of the breeze upper stage. So we've lost the second stage, we've switched on the breeze upper stage, we're starting the next part of the journey. Breeze is taking the wheel, Philippe. It's going to take, what, about another hour and 15 minutes from now. What's Breeze's job?
Well, the Breeze has the important task to bring our satellite exactly on the precise orbit where it should be. In our case tonight, we want to be at the same altitude as Sentinel-3A, just a little bit above for the commissioning phase, 10 kilometers above actually. So the satellite has its own engine and can change its orbit, but this costs fuel, and so it's very important that we have a precise orbit right from the beginning, and that's where it's critical to have a performant and let's say on-target third stage like Breeze will very likely do tonight.
It's a little bit like a sophisticated taxi driver. It takes its passengers where they need to go. Nick, it's a fascinating piece of kit, isn't it? Because it's effectively a spacecraft in its own right.
Absolutely, yes. It has to be very autonomous, so it has to really think for itself and be able to decide when to do exactly what it has to do. It has its own onboard computer with guidance, navigation, control. It has its own tracking and telemetry system. So
you can't hear me.
Tell the Russian experts what it's doing and when it's doing it. it actually has the capability to restart its engine multiple times and perform different maneuvers, so that it can take its passengers to different orbits, or even multiple satellites to different orbits. So it offers tremendous flexibility, but as you say, it has to be very clever, and it's a spacecraft in its own right.
The Sentinel-3 satellites are a key component in the Sentinel constellation, which of course as a whole provides vital services to the Copernicus program. We're going to take a look now at the kind of services that the Sentinels provide.
With more than half its satellites now launched, the Sentinel constellation is providing a wealth of data on land use, the marine environment, the atmosphere, security, emergencies and climate change. By combining Sentinel satellite data with Earth observations, scientists can develop a clear understanding of many of the vital issues affecting our planet.
So yeah,
Sentinel-3, for example, sends back data every day to help scientific projects around the world studying the oceans and the marine environment. Many of these projects, such as EuroHab, which investigates harmful algal blooms, or HABs, can only go out to sea at certain intervals. In EuroHab's case, once every 2 weeks. Sentinel-3 captures a broad view of the production of phytoplankton. The scientists of EuroHab can then take further measurements to break down which species the satellite observed, and crucially, which are toxic. At Plymouth Marine Laboratory, an ingenious device called a smart fin is attached to a surfboard to measure the temperature of coastal water, and the motion of water is measured using a smartphone. Back in the lab, these measurements verify and sharpen an interpretation of the data provided by the instruments on board Sentinel-3.
The temperature of the ocean is a fundamental component of the environment. It controls the physical environment through changes in density together with salinity, which impacts coastal planets.
Oh, I'm such an idiot. What did you do? Did you turn off the volume?
Environment. So the growth and reproduction rates of pretty much all marine organisms are temperature dependent.
While a scientific study can only examine a small part of the ocean, satellites can cover the entire planet.
Your phone can auto-connect it with your car while
at sea, patterns are detected and applications are tested. At Plymouth Marine
let me fix the problem of the camera, guys.
Determine whether plastic and rubbish accumulation in the ocean can be detected from space.
We are going to do a horizon scanning
USB ports
with all the technologies that are available for from Earth observation, and we are considering
there's me. Yay, I'm wearing my headset. Sorry guys, my headphones
other remote
don't plug in.
Like SAR, and as well indirect approaches.
The Sentinel constellation of satellites is at the heart of Europe's far-reaching Copernicus program, providing real-time information 24 hours a day, 365 days a year on the health of our planet.
Do this even.
Philippe, this is really important stuff, isn't it? These services are hugely important, particularly as the world becomes more and more conscious of the need for sustainability.
Yes, and I think that as we've seen in the movie, it's about satellite, but also we shall not forget the importance of all the data that is being gathered
sorry guys.
the so-called in situ data.
I was playing KSP, so I totally forgot about this until basically someone asked me, when are you going to stream? So sorry for this silly moment, but I could try and recreate this in KSP in a short time. But I should install some extra mods, but I don't think you will mind.
And let's not forget that whilst there are institutional services that have been put in place by the Commission, there is also many commercial companies that are now establishing themselves and that are providing added value services, services that you can buy.
Am I still visible?
So
yes.
Copernicus is not only better about environment, but it's also really a commercial and economic affair.
In a couple of minutes' time, the Breeze upper stage will be scheduled to switch its engine back on again for... Sorry, off, I mean, for the first of 2 ballistic phases.
Ugh,
Nick,
now my face is
ballistic
gone.
mean? We do hear the word quite frequently,
oh,
but what does it actually mean, and why do we need 2 burns for this particular mission?
So a ballistic
Never mind.
phase is when there's
okay.
no additional energy added to
so,
the system.
again,
So it's like a bullet. When you fire
let's talk rockets, guys. Because that's why you're here. So the red line you see is the
the reason that we have these
the
to do a 2-burn
boosting phase, and then what's not red you can you see the ballistic phase. So yeah, right now it's what she's telling is they're inserting it in a slightly elliptical orbit, and that's just because probably it has such high thrust they can't go up and do it in one burn. As you saw with a SpaceX launch, or sometimes you can see it with a nice of them to label Earth for us, yeah. But if you look at the Sentinel, I don't know which launch it was. I think it was a Sentinel, but if you see when a so imagine this is the rocket, and this is the engine, and this is the front. So sometimes with the Vega rocket, yeah. Yes, I was forgetting the Vega. When you, those are SRBs, you can throttle them, but sometimes they get too high of a thrust. So instead of turning it off, you can't. You will point it downwards, because that will lower your apoapsis, or your highest point, because it's still in front of you, and it will push out your periapsis, which is still in the earth. It will push it out a little more. So when they have extra thrust, mostly the Vega is programmed to do this. But these engines can turn off, so what they do, they turn it off, and their orbit gets pushed far out, so the outer point of the orbit, which is on the opposite side of the Earth, is a little higher than 500 kilometers. They turn it off, they wait a half an orbit, then turn it back on, and then the lowest point is raised to be as high as the highest point. So,
Sentinel-3B launch campaign manager. She's been leading the teams throughout the campaign. Bruno, let's start with you. I can see Guido there in the background as well. Hi,
I'm gonna get a second screen.
Bruno, you've been very involved.
This is not working. This has been the worst stream ever.
You've lifted off. What's going through your mind after all that hard work?
Well, at this point I have to say that I had not much time yet to think about the hard work we've done before. We're still in a kind of the middle of a climax, which is lasting quite long, 1.5 hours, because the liftoff is just begin. But we have been witnessing so far a number of critical movements, and so far everything is nominal. But we are still waiting for the final injection maneuver that will happen only in 1 hour.
Sorry, guys.
Minutes from now. And
someone should have my phone number, and then next time, if I'm playing KSP, I should tell them, hey, I'm playing KSP, call me 30, no, not 30 minutes, like 40 minutes before you start, so you can fix all your little problems. But no one did, so...
just briefly, people often talk about the Sentinel-3s as the workhorses of the Sentinel fleet. Why is that?
Well, Sentinel-3 is a bit different from the other Sentinel which has been flying so far, or we are under development. Sentinel-3 is a multi-instrument and multi-mission satellite, cover both optical and microwave mission, and as an important objective to provide global coverage of the whole Earth's surface, land and ocean, into a very short time. In fact, with Sentinel-3, with both Sentinel-3 satellites flying, we will be able to give an optical coverage of the overall Earth in 1 day, which is something never achieved before. Just to understand, the predecessor of Sentinel-3 were doing this in 1 week or 10 days.
So
and this is allows Sentinel-3 to provide a basis for all the other missions of Copernicus.
So a very important mission. Patricia, you are the launch campaign manager, I think I'm right in saying, for Sentinel-3B. So you've been leading the teams throughout the campaign. What were the highlights for the team during the campaign to prepare the satellite?
I think every day has been very important for everybody here. There was a very good team spirit from day one.
So will the orbit be circularized or will it remain slightly elliptical? Orbits are always slightly elliptical, if you want to talk correctly, but they will circularize it. That's why this mission is taking so long, because they will circularize it, but the highest point of the orbit right now is on the South Pole. So
all the critical steps were behind, and
you will see me fiddling around now, but I will talk through it. So right now they wait.
Now, and we will be coming back to you in
so yeah.
Just under an hour.
No.